Yes, dear students, in this video I will take the topic motion of charge particle in uniform magnetic field. Number one case, when velocity v is perpendicular to magnetic field B. In this figure, we represent uniform magnetic field by cross. Cross means the magnetic field is normal to plane of board and into it. You will say magnetic field normal to plane paper and into it. Now particle having charge q mass m enter at right angle to magnetic field B with velocity v. So let in figure vector B is normal to plane of paper कहेंगे आप of paper, normal to plane of paper and into it. Sorry बच्चों, I got outside. So let in figure magnetic field B normal to plane of paper and into it. A particle of mass m, charge q enters the field with velocity v, which is normal to B. Normal to vector B. Now, as soon as particle enter the field, it experiences force because at 9 degree we know force on moving charge is vector F is equal to Q vector V cross B. So direction of this force will be at right angle to B and B both and determined by screw rule. This is V, this is B, so V cross B. Away. B inside. This B is downward, so V cross B, so upward force रहेगा. Direction of force this way. So direction of F is as shown in figure, and magnitude F is equal to QVB sin 90 because B perpendicular to B. So OF is equal to QVB. So this force according to this equation is at right angle to velocity V. This is very important here, dear students. Direction of this force is at right angle to velocity V. लिखेंगे यहाँ since vector F perpendicular to V, so it does not do any work on charged particles. On charged particles. Work done, actually you know W is equal to F dot D. Dot proportional to force and displacement, and direction of velocity along displacement. So force and displacement are here at right angle, no work done. And if no work done, then what will happen? Will do does not do any work on charged particles, and therefore from equation, W is equal to half mv square minus half mu square. If W is equal to 0, V is equal to U. What does it mean? I am explaining this fact. This is not written in books. I mean to say here that when force acts at right angle, it does not change the magnitude of velocity. So magnitude of velocity will not change, hence magnitude of velocity will not change. This force changes the direction of velocity. Any force, remember dear students, any force which acts at right angle to velocity does not change the magnitude of velocity. It changes the direction only, because it does not do any work. And the force, if particle remains in the field, direction of velocity will change. Continuously. Hence, path followed will be a circle. Actually, in my class teaching, I dictate this, but I am sending the video, so all these things will be written as well as spoken, so that you understand. Will be a circle. You know, to move on circular path, body needs centripetal force. A body of mass m moving on circular path of radius r with speed v needs centripetal force. Centripetal force F equal to mv square by r. F equal to mv square by r. This centripetal force also is a great trouble for student learners. When body moves on circular path, it needs centripetal force. Why? Why it needs centripetal force? Because according to Newton's first law, listen my statement very carefully. Newton's first law states that a body at rest remains at rest, body in motion remains in motion with constant velocity in a straight line until and unless unbalanced force applied on it. जब तक F 0 है, till F equal to 0, magnitude and direction of velocity cannot be changed. And here in this circular path, body is changing direction continuously. So to change the direction of velocity, we need a force. मैंने ऊपर लिखा थोड़ा सा. If F is equal to 0, then it means by force. What is force? Force is that external push or pull, or that is external force, which can change the state of rest or state of motion. State of motion means direction and speed, magnitude of velocity. So direction and magnitude of velocity cannot be changed without applying force. And here on circular path, body changing direction continuous, so it needs a force which should be at right angle to velocity and is called centripetal force. So centripetal force does not get produced itself when body moves on circular path. The body needs centripetal force to move on circular path. Now this force is body required by the body. From where the body will be obtained? The body will obtain this force. The force F equal to QVB due to magnetic field. Provides this necessary centripetal force. So we can write here mv square by r. Hence you can write r equal to qvb. From here we get r equal to mv upon qb. Means radius of circular path followed by charged particle when enter magnetic field at right angle is this mv upon qb. Larger the mass, greater the radius. For if the charged particle having charge q velocity v magnetic field, greater the mass, greater the radius. If larger the charge, lesser the radius. Greater the field, lesser the field. So radius of circular path depend on mass, velocity, charge, and magnetic field B. Now if capital T be the time taken by particle to complete one revolution. If capital T be the time taken by particle to complete one revolution of circular path radius r, then T equal to 2 pi r upon v. T equal to 2 pi distance, total distance traveled 2 pi r. Velocity v, time equal distance upon speed. Now putting the value of R here, you get 2 pi upon V into mv upon qb. V cancel. So time period 2 pi m upon qb. So time period does not depend on velocity. So if two charged particles having same charge, same mass, enter the magnetic field with different velocity, then time period same but larger the velocity, greater the radius. तो अगर यहाँ चार्ज पार्टिकल magnetic field है and particle enter at right angle to B with different velocities, then path will be like this or like this. It is for velocity v1, v2, which greater? v2 greater than v1. But time of complete rotation same. Now we can talk about frequency, number of rotation per second, number of revolution per unit time. Per unit time is called frequency. N is equal to 1 upon T, so here N equal to QB upon 2 pi M. These are important relations which are generally asked in exam in different ways. So this is the motion of charged particle in magnetic field when it enters the field at right angle. Now I will take next when particle make angle theta with velocity of particle make angle theta with magnetic field. I can do it here. Number 2 है, if angle between vector V and B is theta, कोई भी एंगल थीटा हो, तो इसको मैं समझाते हैं कि B है यहाँ पर, this is vector V magnetic field, this is velocity V, this angle theta. So now velocity can be divided here in two components. This component will be V cos theta, it will be V sin theta. Now component V cos theta parallel to field B. So particle action no force due to component V cos theta, particle continues to move along B, along magnetic B with constant velocity of magnitude V cos theta, while due to V sin theta, particle move along circular path. Circular path of radius R equal to mv sin theta upon qb. So this make it move along circular path. This say ultimately the path will be an helix like this, and so the path will be a helix, and hence path will be helical. Distance traveled by charged particle along B in one complete revolution. In one complete revolution is called pitch. P-I-T-C-H. So pitch is equal to B cos theta into T, यानी B cos theta into MB sin theta अपॉन QB. टाइम तो ये था ना, नहीं तो रीड सॉरी यार, सॉरी टाइम था हमारा कितना टाइम 2 pi m upon QB, सॉरी 2 pi m upon QB. तो 2 pi m v cos theta upon QB. This is the pitch. So what is pitch of screw? होता है pitch. Distance travel particle along magnetic field in one complete rotation. So this was all about the motion of charge particle in magnetic field. When particle enter at right angle to velocity, it move on circular path, and when make angle theta with B, so it move along helical path. This is helix. This is the axis of helix. This distance moved in one rotation. ये यहाँ से एक रोटेशन तो पूरा हुआ है, यहाँ हुआ है, तो this distance is called pitch. Thank you.